Replace. Replace? I need to explain this a lot, and I figured I'd make a video about it. It's the fact that you will have replays in a system, in any distributed system, and you should design your system to actually handle replays gracefully without causing duplication of data or throwing exceptions or being weird. So let's get into it. Let's start with the absolute basics. The autonomy of a network request is that you will make a request to a server. The server will process that request and then send you back the response. Very simple, very basic. If anything happens to the responding message where the server sends it back, it could be a server outage, a network outage, changing networks. If anything happens, you will not know if the message was received by the server or not. It's inherent in a network system. It is what it is. The network itself is unreliable. If you've ever been on a bad Wi-Fi, you know that sometimes you can't send requests to the server, sometimes you can't get requests back. If there's anything worse than a bad Wi-Fi, is a bad cellular network. Now you can think that that is not very common nowadays. We live in big city, But the fact is, if you take your phone, you send out stuff. When you're in your car, you put it on the seat next to you, you keep driving. Your car's a Faraday cage. It prevents network traffic or cellular network traffic to pass through your car's doors. Hopefully they're made of metal. And you will in fact be hopping between antennas or stations in the cellular network. And this is a very common thing. People do stuff with their phones, put in them, and drive away. And then on top of that, you have in the network badly configured or glitchy routers or proxies. A lot of companies have proxies checking everything going in and out of their networks, which is a good security practice for especially larger companies. But if that proxy is configured wrongly or for some reason have faulty hardware or whatever, you're gonna have issues in the network. If we can accept that the network has unreliable aspects to it, if we want to design something that has a guaranteed delivery rate, we will resend messages that we have not received a response to. We do it all the time. Replays or retries of HTTP requests is so common, in fact, that you often it's just a configuration setting in any system that you're trying to send messages with. If the fault is in the wrong place, that will cause duplicates or replays at the server side. If you're designing for a high available system, you will have multiple readers for the incoming requests, and that also are sort of designed to go up and down, especially over when, if you roll out a system update or for some reason you're moving your compute power from one node to another in a cluster setup of computers, then this too will cause an effect where you will in fact have multiple messages coming in to a consumer working on the data. So this is so common, in fact, that if you integrate with systems that handle payments, for example, Stripe, they literally tell you, we will send you messages multiple times to guarantee that they have been delivered. And it is up to you to make sure that you check your data and make sure that you don't cause multiple executions of that incoming data. And integrations is a really good example, because sometimes you have batch work in integrations, especially where you go on modified dates to see, I should send everything that's been updated for this last day or 24-hour session or since the last run. And time stamps in themselves have issues where you will have overlap, but sometimes the system that you're integrating with, especially if you're in a small, mid-sized company, part of systems development, sometimes that date either gets lost, or needs to back up, or like go from a date further back because of a backup, because of the system update, because someone made a configuration change, and all of a sudden the variable name is different in the configuration, and it starts from 0. You'll have all these messages coming in through the integration that potentially also could cause replays. All right, so all of this comes down to the fact that replays do exist in a distributed system. And one of the startups that I've been working on, that I was working at, had big issues with these messages or duplicate things coming in, because we were doing time reporting and material cost reporting, and we were using REST APIs. So we're doing HTTP post to send these new things into our server. And our users, they did exactly what I told you before. They sat down in the car, they entered the time report and material use, and then they tossed cell phone to the side and started driving. So we had all these duplicate time reports coming in. And you can imagine, all of a sudden your invoice is not 4 hours, it's 8 hours, because there was a duplicate entry caused by this. So we, at that company, implemented something called the client-side ID, where we simply marked every request or like every time entry with a client-side ID. If there were multiple requests on it, we knew, okay, cool, this is a duplicate or a replay event. And there's surprisingly a lot of them, especially 10 years ago with the cellular networks that we had at the time. But a smaller town in any country at this point will have the same network capabilities we had in central Stockholm at the time. So the client-side ID is a way to sort of mark up the intent of the user. Oh, these are my 4 hours, I will send them in. A specialization of something that we call correlation ID, or that you sometimes use in networks to follow trace events or trace actions or things that happen in your network. You can have a correlation ID to sort of, oh, this request came in here, and we can track it all the way to the database. There's a nice tooling for that. But if you design this so that the correlation ID actually comes from the client, then you can use this as sort of your client-side ID and use this to also prevent these replay effects coming into your system. So using this correlation ID, we can simply put buffers, or like not buffers, we can put cache checks in different parts of our system before we write data to see, have we already processed this request? Because if you have multiple consumers, then there might actually be a situation where your consumers in your system are working with the same request at once, at least from the client-side perspective. Last but not least, like here's another thing you can do. If you have an event source, you can make sure that the event source contains the ID already, or like you can see, have we already processed the intent of the user in this case. And if you mark up your event source accordingly, either with using client-side generated IDs, or you have a fingerprint, a client-side ID that you can check, or correlation ID that you can check, oh yeah, cool, we already handled this request, we have it in the event source, we don't have to redo it. Having this kind of setup allows you to make sure that if you're in an ERP system, or you're designing a system where you handle time or money or whatever, you can guarantee that the user's intent is captured by the server only once, and you can also be quite confident that replaying the events will not cause these replays. Another thing you can do to sort of prevent having these replays affecting your data is to use an event source. And the event source comes with a lot of other things, but if you have one in place, you can capture either correlation ID, or like have client-side generated IDs, or put a fingerprint client-side ID on the action, or like the request coming in. And then you can have your event source designed so you can see, oh, we already handled this. This is already done. We don't need to take care of it. All of these things that I just mentioned are just ways for you to implement idempotency. And this is actually one of the most important things why I keep bringing idempotency up as a concept. If you at every level in your system can think in idempotent ways, you will help reduce the amount of replays and the effect of replays. You can put all these things in place, but there might be replays anyway, and in a money situation, you don't want that. So what we do when we design an action is, like if we separate an action and an event, that's a separate video. But when we design a request coming in, or write the code for a request coming in, thinking that this request is an intent of the user to do something, and if that has already been done, if the state is already in a state where we've done, then fine, it's good. You got this. If your order is already invoiced and the user has oh, I want to invoice the order, it's already invoiced, you're good. If it's already shipped, it's shipped, you're good. You don't need to throw exceptions. You don't need to sort of do anything because it's already done. You reduce the load of the system. The client, you're graceful for the client doesn't need it. I get it. You might want to capture errors that well, I did not expect to send this event, but then do that using assertions in development mode. You don't need to do that in client mode, or like in production mode, because when you're in production, it might be replays for a different system. It might be someone rolling back and rolling it through an integration, and having your system going bananas, throwing exceptions all over the place for something that is quite normal for us integration to sort of rerun stuff. You don't need to do it, right? You can just, oh cool, we're done, everything's fine. The user's intent is done. We've already accomplished the task that this action is trying to do. So again, if you work on the implementation part of the system, if you're implementing action, choosing what the action does or how it's named is also a good way to sort of make sure that there's idempotency at every level. So instead of having actions called add one, you perhaps might want to consider doing actions that is more, set the number to this. It's more like it shows the intent. I want my time report to show 4. I don't want to add an hour to my time report, because if you add an hour to your time report, and that's how you communicate with your server, a replay of that will be 2 hours or 8 or whatever. Whereas, a replay that you haven't covered for various reasons, bugs happen, of I want to report 4 hours is you will report 4 hours. A replay will still be 4 hours. You're good. So thinking like this helps you introduce idempotency and helps reduce the cost and effects of replays. And also it guarantees your data's integrity in a way that conforms to how the user behaves. Another source of replays is bad UI. You have most users, perhaps not most software developers, but most normal users will not just double click, they'll triple click, they'll hammer the mouse button, especially if they get frustrated because of slow response times, bad networks, etc. They'll just hammer it. Or pressing the submit button on a form, or like on your keyboard, you press the return button 5 times. And if your client does not handle double clicks, and all of that, you will have replays from the client. And that is essentially your software causing the replays. So don't forget, you will probably have bugs in your client-side code. That happens. Having your backend capable of handling that might be a good idea. Okay, so my name's Morten. I've been a CTO of 3 startups at this point. I've been working in software for like 30 years. All I do is build software. It's one of my great hobbies. I want to build software in teams and at like cost-effective levels. And this is sort of what I talk about on this channel. So if you like the content that I have here, or for this video, please like and subscribe. Share it if you think it's helpful for other people. And also I have a newsletter that you can subscribe to if you want. Everything's in the description below. Check it out. You've now reached the end of the video, and now I have to say goodbye. So, okay, cool. Thank you for watching until the end. See you in the next video.